if you can put a 3 in, just so I know if people are working in the field. And otherwise, I'll assume everybody else is trying to like break into the field or is still learning and stuff like that. So, okay, cool. I'm seeing a 1 from professional data scientist. Very great. Yep, I'd love to hear from anybody else. But yeah, if you guys want to just message in, that'd be cool. And otherwise, let's get started. So yeah, this is just an introduction to Snowflake. This is going to be kind of light and conversational tonight, just so if people can, I think that anyone who's coming here, kind of seeing the IPO, being interested in Snowflake, that is the right level of audience. I'm going to try to show you a little bit of technical stuff, but again, in 1 hour we can't dive too deeply. So okay, yeah, let's give it a start. So Snowflake in the news. So as a lot of us probably know, it was backed by Berkshire Hathaway and Salesforce. And when it like went onto the stock market, it was $120 and it climbed up to I think over 300, but then it settled back down to 254. I haven't checked it today. This is just an article I read. And it raised nearly $1 billion, and the valuation now is at 70 billion. So that's pretty amazing for for this company. Good for them. And so like that's a lot of hype there, and obviously a lot of people staying behind that hype. So what is Snowflake? What does it do? And let's find out about it. So what is Snowflake? Okay, I'm just going to move a couple windows around here a bit. Yep, great. So it's a single integrated platform that offers a data warehouse built for the cloud, instant, secure, governed access to the entire network of data, and the core architecture to enable many types of data workloads, including a single platform for developing modern applications. So we'll kind of get into the architecture a little bit here, but the kind of thing is that a lot of systems, obviously we started with on-prem systems and then we did cloud migrations, but a lot of the on-prem systems, when they got to the cloud, there's something called cloud washed. They're not, so the cloud has basically infinite compute and it has infinite storage. So if you take a system that is engineered to be on-prem in the first place, it's going to be dealing with a lot of restrictions. And then when you kind of migrate to the cloud, it won't be built to take advantage of the limitless potential of the cloud fundamentally. And so Snowflake really does this. And as I was kind of explaining earlier, it kind of takes the best in practice for a lot of different configuration you could do for the infrastructure for having a cloud service, and just like kind of default to those best in practice things to make life easier for a lot of people. There's just so much less overhead you have to deal with, and I would say those are the kind of core benefits. So we're going to look at a bunch of those today. So this is the Snowflake architecture. Basically, there is your database storage kind of at the bottom. And next, on the next layer up, we have our querying processing, which is our virtual warehouses. And that's our compute layer. And then basically on top of that, we have our cloud services. So that's your access and control, or your access and authentication, infrastructure management, optimizer. The optimizing is really cool. We're going to touch on caching a little bit, but they use a tiered approach to caching, which means that in a lot of cases, they can really save you a lot on your queries. They can make them so much faster and they just so much less compute. That's really impressive. Metadata manager will also touch a little bit on micro partitions. So that's kind of your metadata, which allows, and this is the best in practice I'm talking about, it allows you to go through Snowflake, the database, really, really quickly and query it really, really quickly. It's crazy. And the security, of course. Here's kind of a look at it. So you've got your centralized storage. They use the term single source of truth, which is pretty cool because if you have been doing data science projects or just working with data a lot in general, kind of maybe a primitive or a naive way to do it is you end up having copies all over the place, and then maybe you're sharing them in a centralized repository, and then you hope that updates, but somebody else needs a different copy that they're going to do some other testing on, and now maybe they've modified it. So which is the main copy? Thing like this, it's can get pretty out of hand, especially for large companies. I think it's like 150 of the Fortune 500 are using Snowflake. So it is largely making the lives of blue chip companies easier. They're going to have lots of data scientists looking at it, lots of data engineers feeding in data and stuff like that. So it's one centralized like storage place that's the copy of all the data. How they allow different tables to be used at different times by different people, but still have it all be the same storage is really kind of amazing. And honestly, it's a bit of the proprietary secret. I mean, I would love to know exactly how they do that. I'm not sure I would have enough data engineering understanding to actually really appreciate it, but it is really amazing. You can kind of just think of it as one database that everyone is loading things onto at the same time and querying and working with at the same time, right? So it's really, really cool that way. So, and on top of that, you've got your loading funnels, and this is your compute level, like your compute layer, right? The middle layer, your ad hoc analysis, so people running their queries and whatever they want to do with the data. and you can be developing applications. And again, on the top layer, you've got your optimization for the queries, infrastructure management, transaction security, and all your metadata, which is all very important stuff. And so the top layer is kind of like the brains of the operation, and then the middle layer is the almost like the muscle of the operation, and the storage is the very bottom. Cool. Okay. So excuse me. It runs on top of major cloud providers. It's a software as a service. All the architecture is managed, no installation of hardware or software. You go directly to entering data and working with it. I'm going to, you know what, because I have to manually switch to my other screen, actually, let me just change my share settings. Let's go like this. So if you guys cannot see my Snowflake, if you can't see Snowflake, then please let me know. If somebody just type in, I cannot see it, but otherwise I'm assuming everyone's seeing Snowflake right now. So basically, you know, as far as it goes, this is pretty much what you see as soon as you create an account. You log right into it. So right now, when you go to the trial, I should stay on topic because I think I'm going to say this later, but if you sign up for trial, you get about $400 worth of Snowflake credits to use, and you log right into the system. You don't have to install anything, set up anything. It's completely just browser-based and all in the cloud, which is really amazing. So you pay for what you use down to the second. So Snowflake credits, as we'll get to as well, are per the hour, but you pay for what you use to the second, and there's a lot of really great features for like auto suspend and things if your compute is not being used for a little bit. Yep, so it separates storage from compute, as I've mentioned, and you get charged separately for those. The virtual warehouses run the queries, the compute engines, pay for the second. Yep, so auto suspend, it's going to be on your warehouse. If you, like, again, that's your virtual warehouse, which is doing your compute. It's auto suspend after 10 minutes. Let's see, just going to move my, here we go. Yeah, so in traditional data warehouses, you often have to pay for storage up front. In this case, you can do it on demand, or you can do upfront. So you have those options, and it's fully cloud built as opposed to cloud wash. So it's elastic, highly scalable, fault tolerant, massively parallel processing. Like, it's just amazing how parallel processing it is, and take advantage of the endless resources of the cloud. Really great stuff. So again, yep, you could just go to signup.snowflake.com to start your trial. This is your unique identifier so it's just identifier, domain, region. This is mine right here. So you'll get one for yourself. That's kind of just a good thing to know as you, as you work with Snowflake. So just kind of pointing that out to everybody. So we'll go and take a look at the roles just quickly. So let's see here. Yep, so this is kind of the dashboard. We're going to be looking at different aspects of it. Right off the start, up on the top right here, you've got your roles, and you can go to switch roles. The default is your system administrator role, but you've got your account admin, security admin, and public is kind of the default role that's up there for everybody, and your user admin. All of these give you different options as with regards to being able to change different parts of the system. For example, sysadmin can create new data warehouses, can create new databases, things like that. Account admin is the very top level, so that's what we'll be in today, so we can see all the different options. Let's see. Great. So yeah, for people who are coming from different platforms, you might think of data warehouses differently. In this, it's virtual data houses that are your compute. Again, so it's good to note. So the architecture, again, is it's a hybrid columnar databases. So the hybrid columnar idea is that oftentimes when you're going to query a database, and traditionally, and it's traditionally like way back, we've had hybrid columnar databases for a long time, but basically you're going to go through the rows. Basically, you're going to go through the row, and you're going to go through the end of the row, and you're going to the next row, and go to the end of that, and you go to the next row and end of that. The columnar approach just allows you to actually just search for columns, which of course is going to make everything a lot faster. Yep, the middle layer is your querying level, massively parallel. And then the cloud services on the back end. So the cool thing about the cloud services is they are independently scalable. So if you're a large organization, or even any size of organization, as different parts of the cloud services start to have more load on them, they'll end up scaling up automatically as well. So you don't have to manage that infrastructure at all. And Okay, and so yeah, so we'll just take a quick look at the databases here. There we go. Okay, so here's kind of our dashboard. We've mentioned roles a little bit. We can go to databases, and we'll go all the way to the top level here. And so these ones, I believe, are all databases that Snowflake came with, and I made this one recently. I just was grabbing some EC2 prices off of Amazon, and I was saving them as a CSV and uploading them just to kind of get used to the Python automation, like the Python connector. So I'll show you guys a little bit about that. But yeah, so this is just kind of the databases it comes with. We'll go into the sample one. Actually, you know what? Let's go out for a second here. When you end up clicking on a database, cool. So if you end up clicking on a database somewhere that is not to actually in the database, you can see that you can get your privileges up here. You set your privileges to whatever you want those to be. That's pretty good. Also, you have the option to grant other people who access the database the privilege to share, like to also give privileges to other people. So we'll actually go into here. And so at this level, you're seeing all of the different tables in this. Some of them are obviously pretty huge, 10.9 terabytes. And let's say we want to go take a look at like a smaller one like web sales. Actually, we'll go, let's just say catalog returns like that. We're going to go in here and we're going to see all of our tables at this level. And yeah, so I'm also pretty sure I want to see if we can find the schemas for the tables, or we'll maybe look at that later. Yeah, so these are all the different schemas for the tables. We've got heaps and heaps of tables here, as we can see. And then we've got our schemas over here. Basically, people have asked me before what this is about. And these are, this is a website, TPC SD, that they took all of the sample data from. So I think they maybe named it in their honor, or this is the schemas that they were using to have the data represented on their own site. But it's just data that you can play with. It has the same deal here that you can also grant privileges to data. So it's very, very customizable, but very easy to do this. Anything else I want to? Great, yeah. So again, this is just looking at the schemas and the tables and things that are available. This is not actually querying the data, but we're going to get to that in a little bit. Great. Okay. Yeah. So let's take a look at a warehouse example. So this comes with a default warehouse, which is your compute warehouse. Of course, it's extra small, but we can go into all the different details as we make it here. So obviously you can assign a name to it. It's really important to note the different credits that that you have to pay. So like 1 hour for the extra small, 2, and so on up to 128 per hour. And 128 per hour, I'm pretty sure is something like, I want to say $400. But we will, again, I've got the actual prices in a second here. How many clusters do you want, or maximum clusters and minimum clusters? So again, if you've come from other systems, this might be a lot more laborious to set up and maintain. Whereas in this case, it's actually it's just all taken care of for you. You can say maximum clusters, minimum clusters, and we'll do auto scaling as needed, which is amazing. Scaling policy. So yeah, in the case that you're doing standard scaling, that is going to be more credit intensive, but the responses and everything are going to be much better. So, as soon as there's high enough load, they're just going to queue up more clusters for you. Whereas if you do economy mode, they're going to do many more checks to make sure that you really need to spin up more clusters before they do that. So again, it'll be less. It'll save your credits more. Auto suspend after 10 minutes. Auto resume as well. So that's, you can just. I'll show you in a second how we could run the SQL to suspend or resume. But basically, if it's off for 10 minutes, as soon as basically another query comes in, it will start it up again. So it's kind of amazing how the infrastructure is just so taken care of for you. Let's moving on. And so the pricing, kind of just a pricing view here. But again, storage and compute are separated. It's based on Snowflake credits, as I mentioned. Currency is translated into credits, and then there's various costs depending on the Snowflake version, which we'll get into. And yeah, so basically when you sign up again for the free trial, you get about $400 worth of free credits, which is great. There's some really cool partner there's a partner portal, I think is what it's called, but basically there's a lot of applications that have partnered with Snowflake, which do like amazing things. So even just to get the $400, you have some sample data in there to try out using the like Data Robot. Basically, you get $400 of compute towards Data Robot, which is pretty cool. Cool. Okay, so let's keep moving on. So yeah, there's the standard version. So you've got the complete SQL data warehouse. So one of the crazy things about it is that it's run on top of, when you first set it up, you'll have the opportunity to choose your cloud provider. To a certain extent that I'm not exactly sure about, there you can have different providers. So it seems like internally, if they need more compute or whatever, or there's some reason, like some of their logic behind the scenes, that they will be able to also run your service across providers, right? And also, they'll also, it's cross region too. So in a lot of ways, sorry if you guys can hear the dog there. We just had my dog come back. He's a little bit loud, so sorry about that. But anyways, so cross region is basically, if you're using Canada Central for AWS and you also want to use the one in Ohio, it will just take care of that all for you. 1 day travel time basically means in the standard version is that if you want to regress any changes you've made for a day, you've got that. Federated authentication is that you'll map your authentications from other providers. So let's say you're using AWS right now and you have all your logins and you have it set up just the way you like it to, you can transfer that over to Snowflake. Also transferring your data, of course. And there's some external functions. There's a lot of external stuff as well, but like there's a Python connector, which is something I'm very interested in because I like automating as everything I can. I'll show a little bit of that later on. The enterprise level, of course, everything's standard, but you get a multi-cluster warehouse and up to 90 days of travel time. And I'm not sure exactly of all the details of that, but basically, if you want to roll back changes to your data, to your single source of truth database, you have that option. And then, yep, there's a business critical level, which is basically extremely high security. This secret secure keys it's for everything I'm working on, to be completely fair, it's completely overkill in the level of security it is. But if you're working with very very private healthcare data, then that might be something your company would want. Yeah, AWS Private Link for failure protection and business continuity. And then basically the final tier is the virtual private network. So you have to reach out to Snowflake directly for that. And that's going to be just the highest level of service. So if we kind of move along here, also these are some serverless features that I wanted to mention that will cost you as well. So people who are thinking about pricing, you've got your data, Snowpipe data ingestion, database replication, and as much as you are going to need that for failure reasons, materialized view maintenance, automatic clustering, and search optimization services, that you can build for that. So you just want to be careful about that. And then basically, so the storage costs, getting into kind of the meat and potatoes of it, is you can do on demand or pre-purchased. So this changes with the region, the type. So on demand is, you know what I mean? You can pay for if you think you're going to need a lot less, especially because it's per terabyte per month, then, if you're going to need, I think an example that I just looked at recently said that if you were using under 60 gigs, it was cheaper to do on demand. But as soon as you pass 60 gigs, even though obviously that's like 6% of a terabyte, you're still going to be cheaper doing pre-purchased. So you have both options there. And this is for AWS Canada Central. And then, so the suggestion, of course, is to do on demand for a couple of months and then assess your needs. And then you can switch to pre-purchased. And then, can I mention that? So they have a really great, so if you go to Snowflake pricing, they have a lot of really good information about pricing, and the pricing guide kind of goes a level deeper, and we'll give you some really good examples and kind of talk about all the different corner costs that you might be surprised about. Of course, like transfer in and out, or if you want to transfer, I think, from different regions. So if you're using Canada Central, I believe your upload to Canada Central, depending on how you do it, can be free. But of course, if you want to transfer to US East or something like that, you're going to have to pay for that. There's a lot of really good information there. So basically the virtual warehouse compute, this is obviously the other half, and this is going to be your biggest cost. I shouldn't say other half. This is the other, just like when you think of how much money you're going to have to pay, you think about your storage and you think about your compute. But of course, your compute is going to be the majority unless you're doing something very unusual. So raise some extra small to 4x. This size determines how fast queries will run, of course. Only consumes credits when running, has auto suspend, and it's credits by the hour but billed by the second. So that's pretty great. And then we can kind of get into how much our, and this is from their, I think this is from their pricing page, but basically the higher level of service you get with them, the more expensive your credits are. Of course, you're getting a lot more service and support on their on their things, so you're going to be having you're going to pay extra for that. But yeah, so that's pretty much it. So if we were to look at an extra small, that's going to be for to run that for 1 hour, then you've got 225 is going to be for one credit. So your cost can really start small and it can very much scale at the same time. Cool. Okay. Cloud services are automatically assigned based on your workload. And then cloud services, yeah, there we go. So cloud services are free up to 10% of your daily compute credits. So if you go over that, then you will have to pay for it. It's the way they do the billing is, in my opinion, I think it's actually quite kind of the consumer and fairly intuitive, but it is a lot to remember when you're going to be looking at exactly how your things are going to be costed out. Yeah, so you do get free transfer within your region, but for transfer between regions, you're going to pay a cost for that. Again, external functions, tables, and exports are going to incur a cost. And again, the pricing guide. So yeah, let's just look at the credit spent in your warehouses. So let's see here. So basically, I'm just going to remember where it is. So you would maybe think that you would see this is kind of just telling me about my warehouses here. But if I want to see how my credits are going to be spent, I can go to my account. And I can see how many warehouses I've got going and how many credits I've used so far. I can kind of see when I've been using my credits. I can also see my storage. So you've got your overall, and of course, these are your different. So your database is going to be your core databases. Your staging is where your stage is going to come into, and then your failsafe is basically like an automatic backup they're going to be running for you. But it's that's non-negotiable as far as I understand. So kind of just giving you a really nice breakdown of where you've been spending your credits. You can kind of deep dive into all of that. I can look at the cloud services, and as it is so far, I've been billed nothing for cloud services because I've been under 10% of what my compute has been. So yeah, that's pretty much it. Again, if you're just looking for that, you just go to your account and you can kind of see everything in here. Of course, if you have your billing methods and everything, and that's all, of course, an account. Great. Okay. So Snowflake so SQL Snowflake Snowflake SQL follows ANSI SQL standard. So I was seeing people asking about different. Of course, SQL is different all over the place. It could run a little bit different. So if you are going to be porting a whole bunch of jobs you had on a different system to it, it's good to know these specifications. I ended up, when I've been working with Snowflake so far, which is again just in test mode, I've been writing everything from scratch, and I found some cases that it were kind of weird, but for the most part, it's just everything you'd expect. Okay, let's see. Okay, we'll jump into resource monitors. Make sure I didn't miss anything here. Great. We'll jump into resource monitors. Resource monitors are really easy to set up, and of course, that's really important if you're going to be, doing any jobs in your. Again, getting used to it, the pricing can be a little bit complicated. So of course, you're going to want to automate all of the monitors as much as you can. It's going to track alerts, track usage and send alert, including the remaining credits. Can set limits to auto-disable warehouses, of course. Can limit the number of credits warehouse can use. Can set alerts as limits are being approached. And then, of course, you've got quotas that you can set. So you can reset the quota at each time interval if you want. You can split over cloud services and virtual warehouses. And yeah, you can trigger or suspend those alerts as well. And so the good thing or kind of one of the important things to know if anybody wants to set up, is that it's per monitor summing and suspending. So you can have, it's basically like, I'm not sure if people will know what many to one, but not one to many means. I just mean that you can take many warehouses and have them all under one monitor, but you can't map one warehouse to multiple monitors. So basically, if you have a bunch of services that are running, if you have a bunch of warehouses that are all running, the monitor that is looking at for like looking over all of them, it's going to sum their credits, and then it's going to do its alerts and its auto disabling based on the sum of all the things that it's looking over. So just that's just something you want to keep an eye out for as you're creating your monitors. That if you're assigning different warehouses to it, it's going to sum all of the credit burn or credit usage, and it's going to be reporting on that. So oftentimes, if you if you want to have specific jobs you're allotting different credits for, and you're being more specific that way, then you want to just create other monitors. Pretty much the point there. And so we'll just do a um, quick little demo on getting our monitors going. So again, from our account setting, we can just go resource monitor, and we'll create a new resource monitor and give it a name, of course, and then credit quota. You know what I mean? And so this is going to be per cycle again. So the default one, of course, is going to be that you're going to restart, like you're going to reset your quota every month, let's say, something like that. I'm actually going to cancel out of this for 1 second, and I disabled this just for the purpose of learning, but if anybody can see the notifications up here, you go to the settings for that. And of course, you can also go to your account or your, where is it? Your preferences and your notifications, and you can just change to web or email, right? So I'll go to my web there, and I'll stop getting my notification. This is just saying notifications are off. So go back to account and a resource manager, create a resource. So we've got so we can set our credit quota basically per month, monitor levels. So again, this can be at the warehouse level, or it can be the entire account if you want to do that. Let's see, we can customize our schedule. So for time zones, when it resets and when it ends, the monitor ends. Just a lot of customization here, which is great. You can do a percentage of credit used, which is great. Suspend immediately. So this is basically just, it's sort of like what's the analogy on the stock market? If you put a market order out, or if you put like a limit order kind of thing, is that in the one case, as soon as it's triggered, it's going to try to shut down, and in the other, like in this case, as soon as it's triggered, it's going to shut right down. It's going to kill it. And I think this is going to be more like of a graceful shutting down. It will notify you, and then whatever. So you've got your options this way, and notify when credits are used. Awesome. And so so as well, all of this stuff can be done in SQL if you want to automate that. So throughout all the things I'm showing you today, there generally is a so as I'm going to enter into my customization stuff like that, this will change what the SQL command will be. So if I want to create this monitor, for many different times or something like that, then I can, I'll have all the code so that I don't have to just keep doing it over manually. They really do make it very easy to automate things. So it's really wonderful. Cool. Okay. So it's that. So partitioning and micro partitioning. Okay, so partitioning speeds up querying and data retrieval by splitting the table into smaller chunks. Each partition is manipulated independently. So if you were to think, this is going to be a lot in your metadata, but if you were to think that you have a large amount of data, like the 10 terabytes that they give you, if you were to have to look through that to find a piece of data, that would be very, very inefficient. So of course, that's not what you want to be doing. And we've had partitioning for a long time to split up the database into smaller bytes so that when we go to search for something, we're not looking through all of it. There is limitations to this, which is data skewedness and maintenance overhead. So basically, Snowflake really does best practices where they're doing micro partitioning, which is kind of like much more advanced, and it's a much more granular partitioning. So it's automatically creating micro partitions that are between 50 megabytes and 500 megabytes. So you can imagine then it's just so much less data to be going through. So it's going to, it's going to group the rows again in a columnar. Storage, so it's basically you can scan the columns directly. You don't have to go row by row. But each micro partition is going to be a group of rows, basically, stored in columns. And then, again, the metadata is all about where things are. And we're going to look at actually, so this stuff, it can off the start seem a little bit boring because you're kind of thinking about it's going to be caching and micro-partitioning, but this is kind of just one of the ways that they use like kind of best in practices technologies to save you money, which is great. So let's see. Is this only so basically you're going to be, when you go to query it, you're only going to query the micro-partition that has your data in it. You don't have to query the whole database, of course, and that's going to be known through the metadata. And of course, so the compression also can be much more granular in the sense that it can be applied on each different micro-partition as opposed to, a wider swath of the database. Somebody just asking a question here. So the person asking the question, HDFS, I'm not familiar with that. In truth, I'm a data scientist, so mostly I work with the data. I'm not too nitty gritty into the data engineering. Um, oh, it's Hadoop. Yeah, yeah, yeah. Oh, no, I know this. I was just looking this up. Give me 1 second. Oh yeah. Oh man, it's like on the tip of my tongue. I was just looking up, like basically somebody was making an argument for how Snowflake is going to be the next step after Hadoop. Correct me if I'm wrong here, but Hadoop is a technology, right, that allows things to be queries to be run much, much faster. But there's still a big problem with that, and I'm sorry, I'm gonna have to try to think about it and get back to you on that one. I today I read the argument for why this is going to be a step forward. So if you want to Google that, of course, feel free to. But yeah. Okay, moving on. Okay, so we'll just gonna read what my demo is here. Okay, great. So we're just gonna be kind of looking at some caching with regards to um, querying the database. So let's see here. Hmm. Okay, there we go. Okay, so um, basically, as we can see right now, so what we were looking at before for the databases is a list of the data, and then of course this your databases, these are the ones, and then I'm going to go and I can have this table here, which is catalog returns with my schema. Um, but of course, I'm not actually accessing any of the data here. If I want to actually get to access the data, I've got to write some queries to start looking at the data. So there's a lot of things we can do on the screen. Um, so for starters, we can change all of this. So we can change my role. I can change which data warehouse I want to go with, and I can also resize it on the fly if I need more. I can change the database, of course, I'm looking at, and the schema as well. Um, let's see. So this is the schema that I made here. The information schema is one that every database, like, so basically, I think these are schema views that Snowflake automatically builds for you so that it can work with your data in an intelligent way based on like Snowflake's protocols. And then this is, of course, the table view, and these are the table I've created. So kind of just a quick example of caching is that right now we can see that this is grayed out. So that means that there is no, this has basically been auto-suspended. So if I go to run this, I should get an error that it's, yeah, invalid save. So it cannot be suspended because it's already suspended. Great. And so the next thing we're going to take a look at is if we want to, so this is one of the tables in the sample data. Let's see the sample data here and see if I can find it again. So the sample data, and then we're looking at the 10 here. CFS 10. Call center. Why am I not seeing it? Nice. Okay, there we go. So yeah, so basically, what we want to do in this case is we just want to count the number of rows in this table, this call center table. So kind of just showing you, as people may or may not end up trying this out, sort of some of like the naming conventions and whatnot, is if I go to the call center here, so I've just obviously searched it here because I couldn't find it. So great, I found my matching schema and I've got my call center, and now I'm going to I can, let's see, view. So I can place name in SQL. So if I like were to go here, place name in SQL, then that's going to just auto-populate that for me. So in that case, I don't have to copy it up myself, because what we do suggest, or what the suggestion is to use the full name everywhere you work with something. Because even though you can go up here to switch into a specific database and use a specific schema, as you'll see in a second, the history when you're running queries is really powerful. So if someone else, everyone else actually who has privileges will be able to look at your query history. And if you're running really complex queries to do, complex things, you can copy those queries over. And of course, if you've written out the entire file paths, then you don't have to, or the entire table path, then you don't have to worry about which area you're in before you run the query. I hope that makes sense. And so, okay, so this has been this. So we know that it's deactivated. So we're going to run this one. We can do, right, so I'm not sure if everybody see it, but there's 54 rows. And so that queried, and one of the things you'll notice is that it's actually has not turned my compute on. Now we know with the auto assume that I mentioned before that as soon as a query comes in, that the compute that needs compute, then that's going to activate it. So what happened here, right? We queried the database. We know that there's 54 rows in it. We counted the rows, but we didn't use any compute to do that. So basically, again, this is the metadata that's kind of at the top level of the architecture that's controlling the micropartitions and everything like that, and it's controlling the caching as well. So basically, it just pulled this data from the metadata, how many rows there were, and it didn't actually have to go to the database. So just this kind of one of the optimizations is pretty impressive. And again, I think I get 10% of my calls, 10% of my credit spend for free from these services. So don't have to pay for that. No compute. Pretty great. Okay, so let's do. Yeah, and so what we can do is, again, is we can, this one I believe will get the staging area going. I just want to check quickly. Right, so that's just to check what's in staging. Again, so staging is, if we go to databases, and we'll go back to tables, go to EC2 here, and basically we've got our stages, and staging is where you're going to be loading up tables before you actually move them into your database. There's a lot of reasons that you'd want to do this. Your kind of database, again, is your single source of truth. It's what everybody's working off of. You might want to, extract, transform, load at the staging level. So they've separated the two. You don't move files directly into the database. You put it into a staging area, and then you load it up there. So if we go back to our worksheets here, we've kind of queried and we've seen that we have this in our staging area. And these are just some EC2 prices that I loaded up here. And now we are going to run the SQL to load them into actually. So if we check right now and we check what is in our, okay, so we've actually got our tables in there. And again, you'll notice that I selected all the data that was in these EC2 price tables, right? And I got however many rows this is, 212 rows. Again, I didn't wake up any compute there. The reason for this is because the, I'm just gonna check what we're doing for time. Okay, we're okay. Because this query was done recently by me, I think within the last, I believe it's within the last day. Could be like 7 hours or something. This query and the results were already done, so it was stored in cache as well. There's 3 tiers of cache. It's pretty crazy. So again, this didn't take any compute for me. But let's say we go to delete everything from this table, and we'll go to run it again, and of course there's nothing in here. So now we're going to move this into the table. Right. And so now what we've had to do is, of course, do that operation. We've pulled up our compute, our virtual warehouse is working again. So, okay, great. So there's a couple more things I want to show here just quickly, was basically the history tab. And this is going to show the different times that it took to run all of these. Of course, we can see that the duration for 920 milliseconds was the duration on the one that actually had to wake up the compute, the virtual warehouse, to actually basically do some work, right? It was almost like, now, okay, we're now going to try to do something fundamentally new, and everything else was done from cache. So you can see that if you're running the same operations and those operations are being cached, the data is being cached, the amount that it's going to be saving you on compute is really huge. So let's say we want to look at one of these operations. We can actually go to the query here, and this is taking us over to the history tab. And so we can see what the SQL is, we can see what the results are, and then if we go to the profile as well, we can actually see how this moved through the system and what different parts went into actually executing this command, right? And so this one took quite a bit longer, and let's see, where is our history? Oh yeah, back here, of course. And so where if we go to, let's say, something that was in cache that took, a very tiny amount of time, I'm going to go to the actual query ID. We can look at the profile of that, and we can kind of see, you know what I mean, what's being run to execute that command. And it's just one node. So you can get a lot of information on on your queries and your commute or your compute, and a lot of ways that you can really make that more efficient. So it's pretty great. All right. So see query history. We kind of just covered that a bit. Of course, you can in the query history you have all the options to filter everything. As you'd imagine, you can filter by user. A really important note is that as long as you have the permissions, you can see any other user's queries, but you won't be able to see their results. And again, this is really great if you want to copy their complex queries and just not have to type it out yourself, kind of thing. Okay, great. So yep, so we kind of mentioned this again was with the metadata cache, the results cache, and the warehouse cache, like the standard hard drive cache. So basically, it's going to go to the metadata first. And this is what I was saying about when we were asking how many rows were in a table. It didn't have to go to the data to actually get that information. It can just go to the metadata. The next level, and obviously, if we're doing something that's more intense than just getting some data about a table, we actually are going to go look at the queries. And if the queries have done recently, it's going to be in cache. So you don't have to run that again. Again, it won't take any commute. And then lastly, the data one is, I believe that's going to give you, if you change the query but you're using the same underlying table, that table will be in your data cache, and it will go there. It will, let's say, pull out new data from that data cache, but that's again, that's going to be cached. And it only is when you do something completely brand new to actually affect the underlying database, like the centralized database, that will actually have to spin up your compute and then actually go to the database. So I hope that makes sense for everybody, but it's I don't know, it's pretty I think it's pretty exciting. So we'll definitely save a lot of money in the long run. Let's see, accessing tables. So we did this, I believe. We accessed some tables here. Yep, I kind of showed that. I'm just going to go back and take a quick look and see if there's anything I missed on. So again, it's just the worksheets view, and let's go and look at the sample data. I did a search here, but you've got all your different ones. You can go as well. You can preview the data. And I wonder if I didn't preview a massive one, but basically what this is going to do, the preview data, is it's going to run select all from that table with a limit of 100. So this is going to give you the first 100 rows. I believe that because I've not looked at this one before, that actually did take compute to do that. And let's see, is there anything else I want to mention here? View details. Of course, this will give your schema, what type it is, and you can get rid of your columns. So this is just a auto-generated row number. This is not actually part of the database. So if you don't want to see that anymore, you can get rid of that, put it back in. Obviously, there's all the view stuff that you would like to have. Okay, great. So we're going to touch on the Python connector quickly. So I've got a little demo for that. This is just something I was working on just earlier today. I believe that it's working. So let's cross our fingers, as first passes of codes end up usually going. But we are going to, let's check what we have in our EC2 prices database, right? So this is still hasn't auto suspended yet because it's going for 10 minutes, but we've got our, how many rows? We've got 106 rows here, and that was our query time. And so let's delete everything from our table here. We'll run that. So now looking at it again, we've got nothing in our table at this point. So we can kind of go back. There's a lot of functions like this. I primarily use Python, but anything that you can do with AWS, it seems like you can also do with Snowflake. Sort of the utility and a lot of the work they've done on like utilities to make it easier for people is very, very good. So yeah, so basically if you want, you can install the Snowflake, I think it's the Snowflake connector Python. Where am I at? There we go. Interpreter. Just get the library. Yep, Snowflake connector Python. So you can, of course, you import that. You've got to have a config file, which I won't share. Just got my secret key and my account details in it. It's pretty easy. Honestly, you're just making the connection, which is connection here, and then you're more or less just writing your SQL. Um, you're writing your SQL as text, and yep, and then you can just execute things. So I believe if my script is going to cooperate here. Great. Okay. So basically, what we've done is we have I've got a CSV where I pulled some EC2 prices from with using the Boto API for Amazon, and I saved them into a CSV, and there's 106 files in there. And then this is just uploading it, and then it's reading the rows and printing them out for me. So if I go back again, we just checked it a second ago, and we ran the delete so that we know there's nothing in here. If we run it now, there should be 106 rows, which is just what we just uploaded about our pricing for our Amazon 2 or our Amazon EC2 instances. So again, really not that hard to do. It did actually take me a little bit of tinkering because I believe the mismatch is in if you're going to upload a CSV, you might run into a column mismatch error is what I found, and so error on column mismatch equals false. I believe it has something to do with the rows. I'm still troubleshooting that. So, if you do come across that, that's something to have heads up. What I did, the workaround I found is that I just selected columns 2, 3, and 4. Sorry, 2, 3, 4, 5 from my CSV that has actually 4 columns in it. You know what I mean? So it's automatically appending one, I think, of the row one, and I just put those into the table. Yeah, I just put those into the table, which had again the 4 columns that I created. So yeah, nothing too hard there as a workaround, but I think there's just, like have to get used to any new system. But I think that the Python connector is really quite nice. And okay, so how are we doing for time? Okay, we're definitely getting close. So I'm going to show you the Partner Connect, which I think is really great, and I can't wait to take a look at, especially because they've given us a nice chunk of data to play with. But basically, go over to Partner Connect here, and yeah, I haven't worked with any of these yet, so I can't quite give you a demo, but there's some big names obviously that they've partnered with who are going to, I would assume, be running their services extremely efficiently on data you have in Snowflake. So like Data Robot's one of the leading platforms for AI. Data World has wonderful amounts of data sets. For our data engineers, there is a lot of, where is it, Stitch for ETL. So there's a lot of really great stuff out there. Some more ETL. Yeah, so this is definitely something that would be worth checking out. It looks like they've got AI for cybersecurity and everything. So yeah, it's really great. So I know that a lot of places like Amazon and whatnot will have SageMaker for their AI, and that will be integrated into it. But there is something really interesting, and I'd have to see how pricing works with having companies that specialize entirely in one thing, like Data Robots AI, then having this kind of seamless integration. I think that's pretty cool. Let's see where we're at. And then, so yeah, that pretty much concludes it. I think there might be like 1 or 2 slides after this, but there are some potential topics for future webinars that I could dive into. If anybody wants to, if there's just, let's say there's ordered from 1 to 6. If anybody wants to type in a 1, 2, 3, 4, 5, or 6, if you are really interested in any of this stuff, so we could load some data from AWS. We could automate that in Python for sure. We could do continuous data integration for Snowpipe. So obviously, if you have data streams and you want to have those ingested in, somebody's saying excellent summary. Thank you so much. Thank you so much for your time. And so yeah, so we've got time travel as well. So these are a bunch of extra, I think these are some of the coolest features of Snowflake, but I obviously couldn't get to them today. And I could do maybe 1 or 2 in an extra webinar. So if anybody wants to give me some, 1 through 6s, give me some direction on what you guys would like to see, I can definitely do something about that. But so there's time travel. So again, this is object history. So if you change it and somebody just makes a big boo-boo and wants to reset everything, then they can do that. There's failsafe as well, which is slightly different. And I think that's internal. And that's internal to the extent that this is kind of like your failure tolerance, but it actually also has a history. And I believe that time travel and the failsafe are going to be stored like they're stored and treated differently, although in a lot of ways it is just dealing with your history. But time travel is something you're going to have access to, and I believe failsafe is something that you don't have access to, that it's sort of like in the event of a failure they're going to roll it back on you. You can have task triggers. So if you're running some service and you want to, once it goes out of once it runs out of credits, you don't want to kill it, but you want to shift it into lower power mode. Or after it's been hit a certain amount of times, let's say it's some web service, a server of some kind, you want to do something else, that can definitely happen. Zero copy cloning. This is something that I have not wrapped my head around yet, but I think is really amazing, is how you can have all of these different people both ingesting data and working with the data, so querying it all the time and running different things on it, but also have it also be like one centralized copy of the data. So obviously the data is in fact being replicated, because that's necessary for for fault tolerance and resilience and whatnot, and availability, of course, all these good things. It has to be being replicated, but how you can have everyone accessing the data, but it still be one kind of centralized copy of data. I don't really understand that yet. I think that's maybe kind of like their dark magic that we're not going to know about, but it kind of blows my mind when I think about it. So I could do something on that. And then of course, Tableau and Power BI for visualization. Obviously that's a great thing to have on your resume. So if anybody's interested in that, but I'm getting some 1 in 6. Okay, great. So the visualization and AWS, I've got a 2 for the continuous data integration, and a bunch of, okay, 1s and 2s, 1, 2, okay, so it looks like the 3, 4, 5s are not getting any love. Good to know. But 1, 2, and 3 are definitely people are voting, or 1, 2, and 6 are getting some votes. So awesome. Thank you for those votes. And maybe a couple weeks from now, I'll do another one that covers all 3 of those. And we can just do some. Now, here's a question for the people who voted for 1, and there's, I think, 7 of you, or whatever. Yeah. So if I also check my Slack as well on my other computer, I think there's about. Yeah. Anyways, okay. So there's a couple people here. If you want me to do like loading from AWS, do you want me to do everything in Python? Would you like it all to be like with a Python connector so it's automated, or would you like me to go through AWS? Somebody's saying yes. I think you want to see it done in Python. So okay, great. That's what I would like to do anyways, because with Python, awesome. Okay, we'll do it from Python. So yeah, maybe in a couple weeks, if you guys want to join us, we'll definitely do at least a couple of these with Python, and then obviously Tableau. I'll go with Tableau as opposed to Power BI, and that I will not really be doing Python. I'll just be. It actually has really nice integration. You just pull the data directly from Snowflake into Tableau, and you can start using it. So that's pretty great. And so yeah, so we've got a Q&A. I'm just going to quickly touch on a program that we run at Be Cloud Ready. And so if you guys found tonight informative, and you kind of maybe are not in the field, but you would like to enter the field, we do have a program that we've created where basically we work backwards from basically projects so it's run by a senior DevOps guy, one of our co-founders, and he would like to hire people. He's a hiring manager, and we were kind of working out what would be skills that we would want to have people to have. So we thought about that, and then we thought, okay, well, how would they demonstrate that? Well, they would have projects. So we want to see that people have a strong GitHub to get into it, especially if they have a non-STEM background. But even if they have a master's in electrical engineering, if they want to get into software or DevOps, something like that, they really should have some projects that they can show us. So we work backwards from the projects to kind of distill it down to some skills. And then we kind of have worked back to creating videos and things like that around those skills. So it's a very streamlined process where we look at job postings, we distill that down to the projects that would get you hired. And, obviously the soft skills and stuff around that, we're going to give you lots of advice on that. And then we work that down to some actual skills, and we teach you those skills, and then we get you on the projects, and then we send you out in the market, and we kind of help you with interviews and stuff like that. So that's just a program we run that I want to talk about. If people want to get in the field and they, I don't know, yeah, if you're interested in it and you'd like to, please get in touch with us. I'm just going to send out my email to everyone. And yeah, you feel free to get in touch with me if you have any questions about the program, or if it's a good fit for you, or just, just in general. I'd love hearing from people and kind of seeing like where you're at. It's a really interesting time, isn't it? Because we know people who are very senior who are looking for jobs. We know people who are very junior who are trying to break in. And there's so many different technologies and everything happening in the the background job field is changing so rapidly. So it's a really interesting time to connect with people. We do have a 1-week money back guarantee. So basically we do a live Q&A for 1 or 2 hours every single day with our students. So you can come out, if you, let's say, don't know Python. I generally start people with Python because it's just a very, very good thing to have in your tool belt is Python. You can use it everywhere, as I've kind of shown with Snowflake today. And we start off with Python, and so you can hang out with us for 5 hours for a whole week if you want, and kind of learn some Python and stuff and see if the program's right for you or not. Yeah, and we have a more in-depth webinar about the program and kind of more career advice, I guess, tomorrow at 7 p.m. if anybody wants to join us. But yeah, that's pretty much it. You can contact us if you're ready, and I'll kind of go back to Q&A now just for either questions about Snowflake or questions about our program, any of the above. And I thank you very much for the feedback that people are interested in seeing, AWS and the continuous integration and probably some Tableau stuff. Those are really kind of maybe the most important data engineer and also analyst / data scientist skills, I would say, for sure. But man, doesn't that zero copy cloning? Does anybody else just wonder how they do that? That seems pretty crazy. Zero copy cloning. Okay, I'm making a big deal of it. I think I might be the most excited person about zero copy cloning. I was looking at some systems design theory recently to kind of understand more about how caching works, kind of in preparation for this, to think, just kind of a refresher about how caching works and how the multi-year caching stuff works. And the amount of caching that they must have in this zero copy cloning, I can't even wrap my head around it. Just really cool. So yeah, okay. I'm not seeing any more questions right now. So I think I'm going to leave it there. I hope everybody found that informative. Yeah, any questions at all? I'll stay on for another like 2 minutes. If anybody has any questions at all, even they can be silly questions. Nobody else will see them. I won't read out your name. I don't even know what your name is because it's probably just a nickname. But if you're just like, oh, what do you use Snowflake for? Or where does Snowflake fit into a typical software project? I want to make a software project. Where do I use Snowflake? What's the point of it? If this conversation was a little bit, maybe, I think, because I see some people who come out very, very often, and I think that's great. I think you're very curious and you want to learn things. But maybe if you don't have a kind of a more general background, and we're doing topical webinars because that's what people are interested in. They want to know, like, Snowflake's brand new, there's a massive IBO, it's now worth $70 billion. Like, we should talk about Snowflake, but where does Snowflake fit into the overall picture of, like, how would you use it? Why would you use it? Why would someone pay you to use it? If you're going to spend, let's say, a couple months learning Snowflake and you're just a wizard at it, what's the business case for it? If you have any questions like that, I'm happy to talk about that for a couple minutes. Yeah. It's a big group tonight, but everybody's a bit quiet. So I'm just going to take it that we're all just kind of absorbing information. Yeah, was there any professionals in here who have really complex questions? Because if you are, and I have another Q&A in a couple weeks, I can make sure I get your I can get to the nitty gritty of things if anybody's really curious about that. Yeah, thanks. How to reduce the traffic cost to main application server. Yeah, so that is caching for sure. Okay, so from what I understand, and of course they've done it in I would expect a very, very complex way on the back end. So I can only kind of point you in the direction of some concepts that are meaningful. So one thing would be a load balancer. So you're going to be, because it's the cloud, you can scale. So you can just keep tacking on more nodes. So you could have more and more servers. So you're going to have a backwards proxy server, which is going to be a load balancer that is going to have some sophisticated hashing thing where basically you're going to be translating you're going to somehow have an identifier for everyone coming in. And then you're going to trade that identifier into pointing them at a server. So you know what I mean? Let's say there's like 4 servers and 4 people coming in. You're going to have a load balancer that's going to sit between the 2 of them, and it's going to see every time that one comes in, it's going to associate that with server number 1. Like I'm 1 and you're 2. And it's going to always reroute you to number 2. And now when you go to, let's say, for example, load up more servers, you are going to change that because now 5, right? But now if there's no 5 coming in, then 5 never gets hit. But now let's say we've got 5, but also person 6, 7, 8, 9, and 10 are coming in. How are we going to change all this? And so the idea for caching is that what I was kind of saying today is that if you do an operation, that operation gets saved in places that are, let's say, between you and the central database. So going to the central database is like the farthest place you can go, and you don't want to go there. So there's lots of servers sitting in between you and the central database that will have parts of the information, so that if you've already told the computer to go to the database, the central database, bring you back some information because you want to see that information, it will keep that information on a server closer to you. And then you'll go away, you'll look at it, you'll do something else, you'll ask for some more information. But next time you come back and you say, hey, I want that same information that I saw a while ago, it won't go back to the central database. It'll go to the server closer to you in cache, and it'll give you it from there, if that makes sense. And so I was kind of pointing to the multi-tiered cache approach they have, where they have actually 3 different layers of caching. And then you use some kind of complex hashing strategy to make sure it's always the same. Because imagine you do this hashing stuff, right? But all of a sudden you've gone from 100 users to 200 users. So now you've spun up 200 new servers. Well, they're all fresh. The previous 100 users, for example, they all have a server they've been working with, which isn't the main central server that they have caches on. So now you have to dynamically reassign people to servers, but you also want to keep the people who already have caches on certain servers still aligned with those servers, right? So this is kind of the idea of, yeah, like hashing and caching. But yeah, pretty cool. Pretty cool how they do it all behind the scenes and make everything still line up. Okay, so I would like to ask the Snowflake users for data analytics only, or there are other uses too, and is it used as transactional database too? Yeah, so as far as I understand, you can definitely use it as a transactional database. You can apparently use it. These modern data platforms is what they're called. They've kind of gone beyond the data warehouse. They've gone beyond the data lake. They're not just they're not just structured like SQL style. Well, SQL is a language, but they're not just like structured data. They're not just data lakes where it's unstructured data. They're not NoSQLs. They're not like just graph stuff. They can do it all. As far as I understand, you can do everything on Snowflake. The data uses, and I love this, is kind of like, what's the business case, right? So at the end of the day, the way I think of it is that sort of everything is becoming more and more data driven these days. So at the end of the day, you want to use the data, the business wants to use the data to make money. So the main way that we think of the business using the data to make money is to gain insight and then make better decisions about, governance and their direction and things like that. Like, oh, we lost a bunch of people last quarter, lost a bunch of users. Why did we do that? We're going to pull them all up and find out they had atrocious wait times when they're interacting with our Q&A, and that probably cost us, kind of thing, right? So that's kind of one way that we think about it. Another way, so that's kind of like the data analysis side. Another thing is you can make applications, right? Is it working as NoSQL too? Yeah. As far as I understand, I have not dove in, but I was looking at some graph stuff, and I'm pretty sure it absolutely will support like graph style databases as well. I'm almost sure of that. I'm like 98% sure, 90% sure, let's say. So maybe do a bit of homework there, but I'm pretty sure that is the case. So anyway, so another way that the business can, of course, make money off data is you can create an application, right? So let me think of a good application that people want to do. I mean, this is something pretty trivial and it's actually free, but for example, the government of Canada is collecting COVID statistics, and I have a little program that downloads it and runs a little bit of stats on me and gives me a nice little graph every day, which was just fun to make. So a government can, a company can, of course, charge people to have access to data. Okay, well, obviously, let's think of a slightly better example, Nicholas. We'll do it. Let's say like Twitter, right? The data, of course, for Twitter is people's tweeting, and they're going to monetize that somehow. Facebook is also a data company. So Facebook, as you interact with it, there's obviously a massive amount of data in the background. I don't know what cloud provider Facebook runs on, but I'm sure you could Google that. I would guess it's AWS. That's my guess. I mean, I don't think they would have on-prem stuff. I'm pretty sure they'd be running on AWS. Probably not GCP, but I don't know. Anyway, so Facebook would have all your kind of posts and photos and everything that you freely share with them, and that's going to be their data. And then they have a web portal or a phone app that you can then interact with that data. And then because they're using sophisticated machine learning to keep your attention, they can also monetize that. They can feed you ads while you're looking through pictures of your friends' cats and whatnot. So yeah, that's kind of, there's basically lots of different ways. We don't really see the data as just like raw tabular data in front of us. Obviously, it's being transformed and surfaced. But I mean, another way you can think of it is like, what's a website, right? A website is just HTML, which is a bunch of data. So you store that on a server, but imagine, you have a website that also presents you other forms of data. Well, you're probably not going to just store that on one server, because if it's a lot of data, it's going to get full. So you want to have that in a database, and then your server is going to go to your database and say, hey, I need somebody wants to watch, YouTube videos of cats. So I need to go to my database filled with cat videos, right? The server, it's going to get a list of those, and then it's going to serve that list to the end user, kind of thing. So yeah, database is just kind of like where all the meat is in the operation, and then it gets served up to people. So yeah, I hope that makes sense for people. Kind of contextualizes where Snowflake would want to fit in. So let's say you want to build some kind of web app and you're going to be doing anything with data. I would really strongly suggest maybe considering Snowflake, because it's just so much less of a headache than anything I've ever seen before. Yeah, you can kind of log in and you can log in, upload your data, and be working with it in minutes, as opposed to configuring our architecture. So yeah. Okay, I'm gonna leave it there. Those are really great questions. And yeah, if anybody wants to join us tomorrow night, we'd love to see you guys out. I see some very familiar names. It's always nice to talk to.